Hello guys, in this short video I will explain about final value theorem. A final value theorem allows the time domain behavior to be directly calculated by taking a limit of frequency domain expression. Final value theorem allows us to determine the value of the time domain equation as the time approaches infinity. So go back to our previous note. Okay, final value theorem state that when times approach infinity, we also can use S domain equation, limit S approaching 0 as time es. Okay, this is the equation, limit time approaching infinity for time domain, and this one is limit S approaching 0 for S domain. So let's find the value of the output after a long time. Okay, from this graph, this is the output graph. Maybe like this. This times. Okay, when time approaching infinity. So what is the value? What is the value when time approaching infinity? We have to know. We want to know what is the value. So we can use final value theorem to find this value, the output value. Okay, to illustrate what is the final value, let's see a few cases of the output response. For first response, like this. Okay. Okay, in this graph, the output, we can see that the output is approaching 1 when time approaching infinity. So in this graph, we can see that the final value of the output is 1. Sorry, FV equal to 1. Final value of the output is 1 when time approaching infinity. Okay, for second graph, let's say like this. Time. Okay, this is the output. You can see that when time approaching infinity, the output approaching 0. So in this graph, we can say that final value of this graph is equal to 0. Okay, next, third one is like this. Our output oscillate. Okay, this is time. So we can see that the output is oscillate all the time. Thus, the output is cannot be defined. So when time approaching infinity, the final value will be undefined. Okay, the third one is the fourth one. Okay, in this graph, when time approaching infinity, the output is also approaching infinity. So we can say that our final value of the output is infinity. Okay. Okay, now let's go to the S-plane. S-plane. J omega sigma. Okay, we know that in S-plane, this side we call right hand plane. This side we call left hand plane. Okay, this side is unstable. This side is stable region. stable region. Okay, from this one. Okay, this area region. Okay, imaginary. Oh, this graph for imaginary and imaginary. We learned a few in previous week about this graph. Okay, FVT, sorry, final value theorem only valid in this region. Final value theorem in this region, which is stable region, together with line origin. So we try to do mathematically. Okay, in graphically, we know that let's say pole is here, pole is left hand side, P minus P. So minus P, graph will be like this. E minus P T. So the final value of the graph is equal to 0. Final value of the graph is 0. This one is graphically. So we also can use a theorem. Okay, we use this theorem, show that final value is equal to limit t approaching 0, s approaching 0, s equal to, okay, for this, okay, in this one we can say that es equal to 1 over s plus p. Okay, s plus p. So limit s minus 0, s time 1 over s plus p. So this one s equal to 0, so 0. So the output will be 0. So the final value 0. Okay, same. This is using equation. This one is using graphical. Okay, for first. Second, let's say at the origin. At the origin, we know that the graph at the origin is like this. Response of the origin is like this. So 1. So that means when time approaching 0, when time approaching infinity, final value is equal to 1 graphically. So we also can use mathematically. Final value equal to limit s approaching 0, s equal to, okay, in this one 1 over s, limit s 0, s 1 over s equal to 1. So final value equal to 1. So same. Okay, this one using equation, this one using graphically. So as a conclusion, other than graphically, you also can use this equation to find the final value. But okay, that's all. Thanks and stay safe. Thank you.